afternoon. I hope I'm audible. Thank you so much, Mr. Jacob. It's wonderful to be here among all of you. And of course, I'm going to fight against your certain tiredness, which would be there at different percentage of time component with you. But in next few minutes, and this will be a rapid presentation as well, so I assure you I'll not bore you too much. But just want to give you a glimpse of a phenomenally emerging biotech innovation system that's happening in India, and would love to see what your thoughts are on that and how we can collaborate going further. So just to quickly introduce the organization that actually driving it from the top is CCAMP. CCAMP is an initiative set up right here in Bangalore, North Bangalore, set up by Department of Biotechnology, Government of India, in India's largest life science research campus, that we call it as BLISC, which has, in addition to CCAMP, has NCBS, INSTEM, and TIGS, which are all national organizations doing all work starting from fundamental research in biological sciences, translation of research, and innovation to solve problems in healthcare, agriculture, and environment. That's where the life science stream actually expands into. Just to give you a perspective, CCAMP was set up as an enabler, a catalyst of high-end research and innovation in the field of life sciences. And just for some of the friends who are possibly from Europe or other places where soccer is a bit more famous than cricket, the analogy would be a midfield player on a soccer field, which actually works with both the defenders as well as strikers to take scientific movement forward. It's very important for you to have a player who understands the language at both sides and makes the movement from the knowledge generation to eventually solution building and product development. And that is very important component which was given as a mandate by Department of Biotechnology, Government of India to CCAMP way back in 2009. And now we are 16 years old, young, whichever way you want to say it. We are in an interesting adolescent phase, getting into adulthood in a couple of years. What have we done in 16 years against the mandate which was given? So these are the three clear mandates, or rather deliverables, which we have put in front of CCAMP. One is enabling research. So we work with organizations across India and even outside to take some of the scientific research forward. Second is translating research which has already happened in academia in phenomenal publication or a patent form, but is not moving forward. How do you translate it forward and make it industry ready, which is one of the biggest issue in scientific world. And third is that how do we take some of the innovations and help them further? In that, this is the first vertical where we have very high-end capabilities in research, be it high-end genomics, high-end capabilities in mass spectrometry, microfluidics, microfabrication, cryo-EM, and many other things which actually enable scientific research forward, be it in startups, be it in industry, be it in academia. And we have the entire gamut of capabilities which is unmatched in the region, not only in India, but in the region under one roof. These are phenomenal tools which have allowed us to work with researchers across India and take the scientific effort forward, and I'm sure industry would like to take the use of it. The second component is that we do research translation with academia, and I think you are very well aware academia leads to amazing new knowledge on what happens behind a particular component, be it in physics, be it in chemistry, or be it in biology. But that understanding actually is just the first step towards building a solution out of it. And that's a journey after that. Many a times, academia feels that the discovery itself is good enough for industry to come and take it. But that is too early. In the parlay of NASA's use of the term called TRL, academia produces something which is at the TRL level 2 or 3, which is right here. What industry wants all the way is a de-risk technology which can be converted into a circle from a square. And the challenge is here the translation, because academia is sitting on one side of the river, industry is sitting on the other side of the river, and the translation is being missed. So this component allows us to build, so there is a program that is run at the national level, both in collaboration with academia and industry, supported by the Office of Principal Scientific Advisor to the PM, by Pratiksha Trust, and one another Spectrum Impact from Bombay. This program allows academic discoveries to be translated to the next level, and we have now developed very large amount of new technologies which are being transferred to industry from the early stages of discovery to the late stages of industry readiness. And this involves something that you just heard about sepsis, I think from my previous talk, which was fantastic, by the way. I don't know how many of you are aware, but sepsis, there is no cure for it. There's no drug. It's a graveyard of actually the drug efforts that is happening. There's no drug. And if somebody acquires sepsis, usually they get 2-3 days before all organs start collapsing one by one, and we lose the patient. And largely, it doesn't happen because of infection. Sepsis happens because you have an infection, other things, your body over-responds. Like COVID, what you heard, your body over-responds to the infection, causes the sepsis. So how do you actually tell your body, calm down, we are all fine, I'm going to give you antibiotic, don't worry. But body goes on overdrive. So this particular molecule, which has been licensed now through a translation to a Netherlands firm, allows body to modulate the immune response and not let it go on overdrive or an underdrive or an inflammatory response. There are several other drugs which we are working on, including in neurodegeneration and many others, which are being taken forward, which I believe is India's phenomenal strength in academia, which was never unlocked before through a translation. And what we are doing, this particular program, unlocks that potential of academia and takes that knowledge further through translation after talking to industry. So that's a second vertical, and I'm being quick and not giving you a lot of scientific stories because of lack of time. But the third one is innovations from across India, and how are we developing those across. So this is just a glimpse and not all of our innovations. We have now nearly 600 innovations in the space of biotech, which in healthcare, in agriculture, and environment. These are all innovative stories which are being there. Out of that, 100 products are in market, and more than in 35 countries. So this is really now from idea to all the way, which we have gotten now, saving lives as we speak across different domains of life sciences in healthcare, agriculture, environment, and within those, there are several domains which we have now the innovative solutions coming through. These are phenomenal ideas which were risky, which were breakthrough ideas that we are supporting through funding, hand-holding, mentorship, what Mr. Jacob talked about, giving them a very conducive environment where innovation can thrive and innovators can thrive. And they are across India, not here, but across India. These are old numbers. Sorry about it, because in hurry I have given him earlier slides. But the recent numbers is that we have now nearly 600 startups where we have nearly 100 products in market. We have funded them nearly $14 million. They have raised $600 million at a valuation of $1.6 billion. And this is really, truly very, very exciting work, because this is now showing that the deep science-based work from India can actually happen and take it forward. Of course, some of them are doing very, very well, and some of these companies, if I give you one-liner and not too much stories, Bugworks is attempting to build what the humanity needs the most. That is actually an antibiotic. I do not know how many of you are aware, but only 75 to 80 years ago, or a little bit more, people were dying because of a simple scratch. Because a scratch happened, infection happened, and we would lose a very healthy person, a young person, or post-surgery, because there were no antibiotics. Come penicillin, that you all have heard of, through Dr. Fleming, suddenly things change. We could treat people for infections. We could do well. But now what has happened, we are in more or less back to the square one, where the bacterial infections have no antibiotics left, because the ones which are there are not active enough against that. We are in the era called superbugs era, where every hospital that I and you know have deaths every day because of infections which cannot be treated anymore. The last broad spectrum antibody in the world, the new class, was discovered in 1960s. Most of us were not born at that time. What Bugworks is doing is from here, it is the world's most advanced company in developing broad spectrum antibiotic. In the phase 1 they are, where they can work on any bug that is present in the world today. All of them are responsive to it. And that is what the humanity needs now, because there are many deaths every year, more than 5 to 7 million deaths happening every year just because of non-treatable, untreatable infections. And that is what they do. Very quickly, just to move from here, the world's only one of the 2 companies which can do stem cell-based suturable cornea. I'm going very fast now. World's most effective company in using for vision disorders like age-related macular degeneration. Their data in the phase 1, where they are developing stem cell-derived RPE cells, retinal pigment epithelial cells, sorry about the too much terms, but they are able to treat a disease which is affecting 200 million people worldwide, 40 million people in India. Global cost for that is $500,000. They are trying to bring it to nearly $10,000 to $15,000. And that data is most effective, better than Roche's company called Lineage. And this is what the science can do. If you do good science and quality, that phase 1 data is best in class in the world. And that is very exciting. C6 is doing ocean farming on actually the farming on the ocean surface, and using the hydrocarbon capabilities to develop products for agriculture and aquaculture and biofuel. This is really phenomenally, completely transformative science that they are able to do. And String is doing something for climate. We all know about climate as an issue. It is caused by global warming. Global warming is caused by greenhouse gases in extra amounts, right? Greenhouse gases are in extra amount. They are able to trap the solar lights back. So warming, so what they do, the carbon burden that is there, the String is actually capturing greenhouse gases from the atmosphere. The methane, one can capture carbon dioxide, nitrogen. So you are able to capture back and kind of reduce the load of carbon in the atmosphere, which actually would reduce the global warming going forward. Using what? Simple microorganisms which are synthetic biology led. So you have now simple small microorganisms which can absorb methane from refineries, from dairies, who can do forward, and many others. And company called Zumutor, which is in the US for cancer therapeutics at the US FDA. So there are several of those, but I think I'm going to wrap up slowly. We lead very large program in India called India AMR Innovation Hub, which has loads of partners which are, absolutely, the resolution is bad here, but global partners are there. We have another global program funded by Rockefeller, Fine, Gates Foundation for the fight of COVID diagnostic against India was led by this program called Index that we started in 2020. And this brought the accessibility and affordability for India by putting together nearly 45 new RT-PCR kits with capacity of having 1 million RT-PCR kits per day at the price of now 250 rupees, which was originally 6,000 rupees. This is world's most affordable RT-PCR kit today for COVID-19. And this happened through the entire process that happened is built in here. I'll not go into details. But this is what innovations can do, and this is what phenomenal science can do as we go forward. We have many efforts in maternal neonatal child health. I'm not going to go into that, but very important segment for India. Many efforts in digital health. We have nearly 100 products, innovative companies in digital health across diagnostics, MNCH, genomics, AI-based drug discovery, digital pathology, and many other components, and agriculture as well, which I will skip for now, as well as the environment and climate altogether. This has all been possible because of global support, national agencies, international agencies who have believed in our work, collaborators like Mr. Jacob who believe that science and scientists and innovations and innovators actually need support, and we have to build environment and collaboratives which can actually help them and do it forward. So we are very open for inputs and collaborations going forward with you. We believe we are just at the tip of the iceberg. We need to do a lot of it at much higher numbers, and we hope that we can do that. So I'll stop here. These are our contact details, but looking forward to your inputs. Thank you so much.